We got that. Okay? So today with concavity, there's two types of concavity. Concave up holds water. You know, so think of like a cup. If you cup your hand to hold something, that's concave up. It's got that little dip in it, right? Concave down is the opposite. Spills water, right? So anything that's curved this way is concave down. Anything that's curved this way is concave up. That's the way to look at the picture, okay? So we're going to use what's called the second derivative test. So if the second derivative is positive, it's going to hold water. It's concave up. If the second derivative is negative, it spills water, concave down. If the second derivative is 0, it's neither concave up or concave down. It's what we call an inflection point. So you can see two inflection points. These two dots are called inflection points, right? Before, it's kind of concave down. After, it's concave up. It changes concavity. Before, concave up, holds water, spills water. Okay, so that's what inflection points are. So they're kind of like critical values, but for second derivatives. Okay? So yeah, inflection points are where that changes. Where does that change? Right? Concave up to concave down or vice versa. Okay, to determine inflection points, we will find the critical values, but for the second derivative. So today we're going to be looking for, so anytime it talks about concavity, concave up, concave down, second derivative. Anytime it talks about increasing, decreasing, first derivative. Okay, that's the differences. All right, and then here's some pictures. I wanted to draw more pictures of what concave up and concave down looks like, because sometimes it's hard to tell, right? So concave up are these guys in yellow. I'm going to highlight them in yellow. So concave up is here, here, and here, where you kind of cup your hand to hold something. Concave down are here, here, and here, where you cup your hand the other way to not hold something. Hold, not hold, those kind of things, okay? That's visually what we're going to see. Okay? All right. Okay, so let's get to the first one. Number 1 on the back of the first page. So determine the intervals where it's concave up, concave down, and where any points of inflection are. Okay? So those are our key words. Concave up, concave down, inflection. That means second derivative. Second derivative. Okay, so the first thing I have to do is find the second derivative. Okay, well, to find the second derivative, I have to find the first derivative. So the first derivative is 3x squared minus 6x. Doesn't say anything in the question about increasing, decreasing, so I don't need the first derivative. I need the second derivative. So that's going to be 6x minus 6. So how did I find critical values for first derivative tests? What did I do after I found the first derivative? So I'm going to do the same thing for second derivative. Set it equal to 0. And solve. So add 6 to both sides. Divide by 6. You get 1. Okay, so that is an inflection point. There's an inflection point. Inflection point. All right. You hear that word inflection points. You hear it in everything, not just in math. Like today is an example of an inflection point. We have an election. After today, maybe after today, if they can count all the votes, we're going to have a new president. Not today, but a new president that's going to come in. So it's kind of an inflection point in our history, right? Anytime we get a new president, that's an inflection point. It changes, right? There's a change going on. That's an inflection point. It changes from concave up to concave down, or vice versa. Okay? We just don't know which one it is yet. How do we do that? Well, draw a number line. We only have one inflection point, so we're only going to put one value on there. We're going to do the same exact thing we did with second derivative, or the first derivative test, right? We're going to pick a number bigger than 1, pick a number less than 1.
Which derivative are you using?
This is the second derivative test, so we're going to use the second derivative. Yeah, good question. Which one would we use? Well, it's the second derivative test for concavity, right? So that means we're going to use the second derivative. Okay. If we were checking for increasing, decreasing, that would be first derivative. But this is concavity. So I need to pick a point before 1, 0, -1, -2, whatever number you want. I'll pick 0. So I'm going to plug that into the second derivative. I get 0 minus 6, I get -6. So negative when it's less than 1. Oops. Now I'm going to pick a number bigger than 1. 2. Twelve minus 6 is 6. 6 is positive, so it's going to be positive here. So that doesn't mean it's decreasing before 1 and increasing before 1. Where is it increasing, decreasing? I have no idea, because I didn't do a first derivative test. What this is telling me is concave up and concave down. Okay? So when the second derivative is negative, concave down. When the second derivative is positive, concave up. Okay, so let's write that down. Concave up, concave down. So concave up is from 1 to positive infinity, because it keeps going. Concave down is from negative infinity to positive 1. And then you have an inflection point at x equals 1. Okay.
What would that look like exactly?
So it would be a change. So at 1 would be one of these dots. So ours went from concave down to concave up. So it would look like, probably like this, the middle one, because it went from down to up.
Will you ever get a concave that looks like one of the ones you showed?
These guys are right?
No, up. Will you ever get one of those concaves or no?
No, because this one won't, because this is always holding water and there's no change here. Yeah, with quadratics, there's no change because it's either always holding water or always spilling water. Right? The ones that change are, these are cubics, right? This is a cubic too. Yeah. Okay. All right, let's look at example number 2. Example number 2, same thing, concave up, concave down, inflection points. Anytime you see any of those 3 things, second derivative.
Would we use the quotient rule?
If we need to find the derivative, we're going to, that's still a possibility, right? We still have those rules. So our first step is, we got to find second derivative, right? So first step is first derivative. And to find the first derivative, we're going to need the quotient rule, yeah. Okay, so low squared. Quotient rule says low times the derivative of the high, which is 0, minus the high times the derivative of the low. So if I distribute a 0, it's just going to be 0. And then I distribute the negative and distribute the inside, I get negative 8x over x squared plus 3 squared.
We simplify the square.
What do you mean, the which part?
The square part or no?
To the bottom?
Yeah.
What do you mean simplify it?
Like,
Multiply it out?
yeah.
No, no need to. Yeah. Just leave it like that, yeah. That's the first derivative. Now we got to do it again because we got to find the second derivative. Okay, so the bottom squared. So if I square the bottom, it's already squared. So it's going to be to the 4th power. Okay, so low times the derivative of the high, which is negative 8, minus the high times the derivative of the low. To find the derivative of the low, I'm going to have to use the chain rule. So move 2 to the front, x squared plus 3, derivative of the inside is 2x. Okay. So the bottom is going to be x squared plus 3 to the 4th power. The top, I can't distribute the negative 8, so it's just going to be negative 8 parentheses x squared plus 3 squared. Minus, and then on the inside I have, I'm going to multiply all 3 of these guys. So it's going to be negative 32x squared, x squared plus 3. Distribute the negative, it would just be plus. Negative 8x squared plus 3 squared plus 32x squared x squared plus 3. Bottom stays the same. Okay, so that's the second derivative. Yeah, we're going to do that in a second. That's the, yeah. So for right now, I just want to stop there. That's the second derivative. What do we do with the second derivative? After we found the second derivative, set it equal to 0, right? Well, it's got a top and a bottom. So set the top equal to 0, set the bottom equal to 0. So the top equal to 0. And then the bottom equal to 0. Okay. And then solve for x. Okay. So solve one at a time. So I'm going to solve this guy first. Actually, you know what? This guy. Let me solve this guy first because this one's not as long.
Nothing?
Well, yeah. Why is this guy not going to give me an answer?
Because no it's going to be positive.
There you go. This guy won't give me an answer. I mean, if you don't believe me, you can find this fourth root. The way to solve this is to do the fourth root of both sides. The fourth root of 0 is 0. But if you subtract 3 from both sides and then take the square root, you get an imaginary number. Square root of -3 is imaginary. It's not real. So this side is not going to give us anything useful. Okay, go to the other. This will. Well, we have two, here we have two binomials. Yeah, we got this guy here. They're joined by a plus sign in the middle. And we got this guy here.
You can factor out something.
Yeah, what's the most obvious thing they both share?
-8x² + 3.
Yeah, so I'm not worried about, so yeah, you could do -8 and all that, but let's take out the big thing. The big thing is x² + 3, right? So I'm going to factor out an x² + 3. So the blue guy has 2 of them. So he's still going to have 1. So what's left is -8 x² + 3 plus. The green guy only has 1. So that one's going to be gone. So it's just going to be 32x². Okay. So now you're going to set both of those equal to 0. x² + 3 = 0. Which will lead me to nothing again. And then this guy equal to 0. This guy's the same thing. It's not going to lead me to anything but imaginary. This guy over here, I will actually get an answer. Distribute the -8. Combine like terms. I get 24x² minus 24 equals 0. It's got a GCF of 24 because it's a binomial. x² minus 1. So it's going to have 2 answers. +1, -1. Those are my inflection points. I have an inflection point at +1 and an inflection point at -1. Again, the hardest part about all of this isn't the calculus. That was not calculus part. That you guys did last year. Because I'm doing that exactly right now with my Math 3, all this stuff here. So the hardest part about all of this is not going to be the calculus. It's going to be the factoring and solving and stuff like that. Okay, so I have +1 and -1. Let me go to my number line. -1 and +1. So I need to plug in into the second derivative something less than -1, something between -1 and 1, something greater than +1. Again, I don't care what number I'm going to get. I just want to know if it's going to be positive or negative. So we're going to do a lot of mental math on this one, so we don't have to do the calculations. Okay, so I'm going to first plug in negative 1. Or sorry, negative 2. Let me run out of room here. What we talked about, a lot of these are always going to give you positives. Like the bottom of the second derivative is always going to give you a positive. Okay, so I'm going to break this part up. This here is going to be a positive. Let me use a different color. Let me use blue. This here is always going to be positive. This here is always going to be positive. This here is always going to be positive. So really, it's negative 8 times a positive, which makes a negative number, and then a bigger positive times 32. So is the top going to be positive or negative? It's going to be positive. The top is going to be positive. And then the bottom, well, it's always going to be positive down there. So that means we're going to get a positive number. Zero. Well, 0 cancels a lot of things out, hopefully. When you're doing mental math, it's nice because you don't have to write down much. But you got to be able to do mental maths. Okay? So if I plug in 0, let's see what we got. I'm going to get 0 on the bottom. I'm going to get a positive on the bottom. We already know that. Positive on the bottom. Okay. I'm going to get a positive here and a positive here. So again, I'm going to have a negative times a positive, which is a negative, and I'm going to have a positive times a negative here. Now, which one of those is going to be bigger, positive or negative?
Negative.
No.
Isn't the 32x squared being multiplied by 0?
Oh, yeah, sorry, yeah. You're right, this is 0, right? So that means this is going to go away, right? Yeah, that's going to be 0. And then 0 times this guy is going to be a bigger 0. All right? So that's just going to leave this guy up here. So that's just going to be a negative because it's negative 8 times a positive. So that's going to be negative. Negative divided by a positive makes a negative. Bigger. Now the last one bigger than 1, I'll put 2. So let's do some mental math again. Bottom's always going to be positive. Doesn't matter what you plug in, it's always going to be positive. So this guy is going to be negative 8 times a positive. Negative 8 times a positive. Okay. This guy is going to be 32 times a positive. Well, 32 is bigger than negative 8, so it's going to end up being positive here. Okay. Positives mean concave up, negatives mean concave down. Okay, so we got inflection points. Now let's do where concave up and concave down are. Concave up, concave down. Concave up is negative infinity to negative 1, and then 1 to positive infinity. Concave down is in between negative 1 and positive 1. And then inflection points at 1, x equals 1 and x equals negative 1. Okay, again, the hardest part about that one wasn't the calculus part. It was the mental math, the factoring, the solving, that type of stuff. That's going to be the more difficult stuff to do. But that's stuff you guys have done before. It's not anything calculus-wise. Okay. All right. Okay, so let's look at the next one. Okay, so the next one, before the next one, there's a little table here. Because what they're going to do here, what they're going to start doing is combining what we did last week with what we did this week. Last week, we talked about first derivative test, increasing, decreasing. This week, we're talking about second derivative test, concave down, concave up, right? Where do they mix and match? What does the picture look like? Okay, so for example, if you have a first derivative that's positive and a second derivative that's positive, you're going to be having something that's increasing and concave up. Okay, that's one example of it. If you have something that's first derivative is negative, but the second derivative is positive, you're going to have something decreasing, but still concave up. Okay, so this kind of gives you a picture of what it looks like, of what it would look like in your head. If it's hard to see, what does increasing and concave down look like? Something similar to that, where it's increasing, but cupped down. Okay? All right, so here we go. Example number 3, they want us to know where is it both decreasing and concave up. Okay. So before I even do anything, I need to figure out what does it mean when it's decreasing. When I say something's decreasing, what does that mean? What's our justification for that? First derivative is negative. Good. First derivative is less than 0. Good. What's my justification for concave up? We just did that. Second derivative is positive. So we want to figure out where f is both first derivative negative, second derivative or positive. So to do that, we're going to have to do both the first derivative test and the second derivative test. So a combination of what we did last week with what we're doing today. Okay? Okay, so first derivative. First derivative test. 6x squared minus 60x plus 54. 4. Set it equal to 0. This actually has a GCF of 6, so I can factor out a 6 from everything, divide everything by 6 to make the numbers a little smaller. Okay, so I'm looking for something that multiplies to be 9, adds to be negative 10. What are the two numbers that multiply to be 9 but add up to be negative 10? Negative 9, negative 1. Yep. Negative 9, negative 1. And since a is 1, you don't have to divide anything. That's going to be the factored guy. Okay. Set each of those equal to 0. Okay, I'm going to get two answers. 6 equals 0 is not a true statement. So I'm going to get x equals 1 and x equals 9. Those are critical values. Those are critical values, critical points, whatever you want to call them. They're not inflection points because this is the first derivative. Okay, next number line. Positive 1, positive 9.
Does it matter which one we do of those two?
Nope, you can use this guy. You can use this guy. You can use this guy, because all of those are different variations of the first derivative. So pick a number less than 1. Well, 6. When you're doing this part, I don't mind if you do mental math. I write it out because it's the notes, but if I was doing this on, to save time, you can just use mental math to do this part here. Because zeros, if you put zeros, that's just going to cancel out that. You're going to end up with the constant, yeah. So that's positive. Now you're going to plug in a number in between 1 and 9. 2, 3, 4, 5, 6, 7, 8, whichever one of those you guys want to pick. So again, this part here you can do in your head. I don't mind if you do it in your head. I don't need to see work for this part because it's just checking to see if it's positive or negative. I'm just writing, the only reason I'm writing it out is because it's the notes, but you can do this part in your head. So 6 times 4 is 24. Minus 120 plus 54. That's going to be negative. It's going to be negative 60 something. 62, I think. Last one, bigger than 9. 10. 10, 10. 6 times 100 is 600. Minus 600 plus 54. 54. Positive. So it's increasing from negative infinity to 1, decreasing from 1 to 9, increasing from 9 to positive infinity. But I'm not done yet. I have to figure out where it's also concave up and concave down. Okay, concave up and concave down. So to do that, I need the second derivative. Second derivative. Okay, so the first derivative we had, the second derivative now. So the second derivative is going to be 12x minus 60. Which is 5, yeah. Add 60 to both sides. Divide by 12. You're going to get 5. Remember, since this is the second derivative, that's an inflection point. Second derivative test. So plug in a number before 5, plug in a number after 5, and you're done. So 12 times 0 minus 60, that's just going to be negative 60. Bigger than 5, 6, 7, 10. I'm going to pick 10 since it's a nice round number. It's easy to multiply times 10. 120 minus 60 is positive 60. So for the same function, it's going to be concave down, curved downwards, from negative infinity to 5. And curved upwards, concave up, from 5 to positive infinity. Now is the part where we have to kind of put them over on top of each other. So it's not the same numbers on the number line, right? I have 1 and 9 for the first derivative, 5 for the second derivative. So if I were to take this guy and put it right on top of those, I'm looking for negative, positive. So where would it be negative, both negative and positive? So let me put it on the board here. Sometimes it's hard to visualize because you're trying to move things with your mind, and that's spatial thinking is one of the hardest things to do. So here, we had negative. Here we had positive, positive. Okay, that's that first one. Now I'm going to take this guy and put it right on top. So there's 5 here, right? And then we said after 5 is positive. Before 5 was negative. Okay. So we're looking for negative, positive. So where is it negative, positive?
1 to 5 would be negative.
Well, yeah, so be careful with what I say by negative. First derivative, right? So this guys were the first derivative. These guys were the second derivative, right? So it would only be from 5 to 9, yeah. Because 5, first derivative has to be negative, second derivative has to be positive. Where do they overlap? Right there. So from 5 to 9. From here, from negative infinity to 1, it's the opposite. It's increasing and concave down. We're looking for that. We're looking for here. So where does it? This is the only interval. From 5 to 9. Okay. So we would say in f of x is increasing, or was it decreasing? Decreasing, sorry. F of x is decreasing and concave up from 5 to 9. Done. Those are very popular. Those questions are very popular questions because it's 2 for 1. I can ask a first derivative question and a second derivative question all in one, as opposed to just asking one or the other. So they're very popular for that reason, because you get it, like I said, 2 for 1 question. Okay. All right. Okay, last thing. Last thing we're going to do, I want you to try number 4. I want you to do number 4. Give that one a shot, and then we'll be done for today. Okay, first derivative test. Set the derivative equal to 0. Solve. I get 3 answers. I get square root negative. I get the square root of 3, positive and negative, and I get 0. Okay. Square root of 3 is between 1 and 2. Negative square root of 3 is between negative 1 and negative 2. Okay. All right. So first derivative. Plug in a number less than negative. So negative 2, negative 3. I'll pick negative 2. Again, you can do this part in your head. If you can, that would be fine. This is okay with me. This part I don't need to see on paper. If you can do that in your head. Square root of negative 3, or sorry, negative 2 cubed is negative 8. So 24 times negative 8. And then these two guys would be plus 144, I think. That's going to be 192, I think. Negative 192. So that's going to be a negative guy. Okay, between negative 1. So this is going to be negative 24 plus 72, which is positive 50 something, 40 something. Okay. Okay. Let's see, positive 1. Let's see, positive 1, it would be 24 times 1 cubed minus 72 times 1. So you get 24 minus, so that's going to be negative back again. Bigger than square root of 3, so 2, 24, 2 cubed minus 72 times 2. This one's going to be positive because 24 times 8 is 192 minus 144 is positive. Okay. When we come back tomorrow, we'll finish this one with second derivative and then compare them. Okay. That's essentially it. You guys have seen everything. There's a couple things. There's a problem with E in it. There's some trig stuff, but it's essentially the same thing you guys have been doing. It's same thing, same idea.